Hey guys, and welcome back to this video. It's the second part to the lab we call Introduction to Graphing. Now, what we're looking at this time is to try and establish a relationship between the area of this, say for example, in my case, a piece of pipe, to establish the relationship between the area of this piece of pipe and the radius of this piece of pipe. Now, the thing is, you already should have, well, essentially these radiuses, because in another portion of the lab, you used a caliper to measure the outside diameter of this piece of pipe. So now, in order to try and calculate the area, all you would need is a piece of this graph paper. Now, my graph paper is 1 centimeter by 1 centimeter. So each of these is 1 centimeter square. But all you'd have to do is get around the graph paper, or set your pipe on the graph paper, and then come back to it with a Sharpie or some other object, even a pencil, and trace around the outside of the object. And when you're done tracing it, you'll be left with a circle just like this on the graph paper. And so at that point, it becomes pretty easy. All you're going to have to do is come back, for example, like that one's 1. Try and add up, and so this one would be like a fraction. So you might call that one. This is where you're going to have to do some pretty good thought. So like for me, that looks somewhere along the lines of, I don't know, that's what, maybe 0.3, maybe 0.4. Anyway, you're going to have to find the area of each of these little pieces, and then you combine them all together, and that way you'll have the area for each piece of pipe. Now, what we're going to do is this. If you don't have access to materials to actually do this lab, I'm going to put up a screen with literally a bunch of circles on there. And so from that screen, you should be able to go back and try and find the area for each one and use the diameters you recorded earlier from doing this lab. So anyway, good luck. Okay, so we've kind of reached the point now where it's going to be on you to kind of go through, take a look at this data, and what you need to do is estimate the area for each one of these circles. So essentially what I've done is traced each one. I've given you the diameters measured with a caliper, and you should be able to go back through at this point. And you may have to like zoom in. It would be even better if you could print this sheet off, obviously, and try and estimate each one of these areas so that you'll be able to make your graph. Now, what I've done, we want to move on. Your data table, you can see you've got a diameter, a radius, and area column. Now, what I've done is I've already made these measurements myself. And what you're being asked to do is this. You're being asked to make a graph of area, which the unit should be centimeters square. Each of those little cells on that graph paper was a centimeter, versus radius, also measured in centimeters. So every bit of this is something you can do in Google. So even where it says radius, you've already got your diameter. Let's take advantage of the computer. Radius, for me, I'm going to grab cell, what is that, C2? And let's divide that by 2. And so that is a very quick way to calculate not only that radius, but drag that and grab it and pull it down. And now I've got all my radiuses. So now let's do what the instructions ask. Let's make a graph of area versus radius. So insert, chart, and hey, it's actually pulling up an insane looking graph. And so I actually hate to say it, but I'm sorry, Google, I appreciate that, but no, go away. Let's try that again. Insert, chart, and now let's go over here and go to scatter plot, and it's going to say, okay, what would you like to graph in your scatter plot? Well, I'm going to say I want to grab the area data, so I'm going to grab it. So cell D1 through D6, Google knows that that's a header. Okay. And it gives me a little bit of a graph, but now I want to go down here to the x-axis, and I want to make the graph, my x-axis, I want that to be my radius. So I'm going to go highlight my radius column, and there's my graph. Now, when I first look at this, it doesn't look so great, but I'm going to go in, and I do this every time I make a graph. I'm going to give it a title, and I'm going to tell it what my axes are. So in this case, this was a graph of what? Area versus radius. And then also at the same time, and look how it updates your graph. Radius is my horizontal in centimeters. Always type your units in. A graph doesn't mean a whole lot without your units. And then for the other position, that's my area. That would be in, ooh, cool units, centimeter square. And I have to do the little caret for my square. Now, so that's got that taken care of. But usually what I'm after is this. I want to put a trend line on there. I want to draw a line through my data. So I'm going to click trend line. And when I do, this is not like the other graph that I did. This data is, well, essentially what it's saying is, see where it says linear over here? This is not a linear graph. So kind of the goal in this section of the lab is this. I want you to try and figure out a way how to linearize that graph. And that's the part where you should probably be looking at me going, Mr. Cole, linearize? That's kind of a crazy word. Well, it comes down to this. We did the graph and we came out with this curve. And so what we're trying to do is this. We're trying to figure out the relationship between area and radius. And so if you think you figure it out, the relationship, you can regraph that. And if it becomes the goal is this. That's what the word linear means. We're trying to make a straight line. So if we can make a straight line, we know we understand the relationship. Now, the thing is, most graphs you do in science are going to fall usually one of three basic looks to them. If it doesn't come out straight, then you've probably got that function. And by the way, you've drawn this in math class, especially if you take calculus so many times. You've probably seen this function in math class before. And then also there would be this function. So the idea is this. What is the equation for that line? If you were looking at that graph, oh, wait a minute, that's y equals, that's a parabola, it's y equals x squared. So the goal is this. If you can recognize this, then go back and redo your graph. Area in centimeters square versus radius. I'm just going to write r square, and the new units would be centimeters square. Sorry, my screen is going absolutely insane. Thank you, Microsoft Surface. You are a valued component of my day. Wow. I guess obviously it does not like. That is like crazy, weirdly cool. So anyway, now that my Surface Pen is apparently broken, we know that the units for that should be centimeters square. We're going to, you know that that's there. I'm going to try and like move on to another page so that we can finish this lab. So let's go. Let's make the graph, instead of area versus radius, let's make a new graph. So let's go up here, insert, chart, and we'll do a scatter plot. Every graph we're going to make this year is a scatter plot. Get out of my way. You're always in my way, graph. So let's go in here, edit chart. I want a graph of, I want area once again on that axis. But you know what? I forgot something. I want to graph radius square, and I don't have that yet. But the cool thing is, that's an easy fix. So let's just make another column. We don't have to calculate this kind of stuff by hand. So let's do a radius square column. Centimeters, the unit would now be centimeters square. And now check it out. Let's do a formula. Equals, in this case, there's my first radius cell, and do shift 6, get my caret, square, bam. And now once again, all I have to do is format that whole column, and I've got it. So let's go back to this thing. We've got our areas. So now let's go in, let's add an x-axis. And I want my x-axis to be that radius square. And now when I do that, now obviously you need to go in. I'm going to get this drug back out of the way. You need to go in and completely update this graph. As in, you need to put a title, you need to put area, you need to make sure and tell what this is a graph of. I obviously am not, for the sake of time, But I am going to go in, though, and I'm going to do something. I'm going to go to Series, and now I'm going to add a trend line. And yes, this one makes a beautiful straight line. So now I want to go and do one more thing. I want to label this with an equation. So let's use the equation for the line. And so I've got this. What have I got here for an equation? I don't think I can copy and paste off this. If somebody from Google Development is watching, you should really make it where somebody could grab this and just copy and paste it. So we've got what, 3.13 for a slope on here? Yes, I'm still trying to get it to let me get in here, and it's not doing it. And then, holy cow, times 10 to the negative 15 for an intercept. Well, let's go back over. Let's grab a blank page real quick, or better yet, let's take a look at this. Here is, this is the lab. This was our first graph, and we did what was called the 4-step analysis on this. We went through, and we kind of tried to sign this thing up and see what we can do. So let's take a second and see if we can go a little bit further here. So that other graph we did, let's see, there we go. All right, got my pen working again. We did this graph and we found the slope on it, and we did this 1, 2, 3, 4-step method. Well, here's that 4-step method. I kind of laid it out and gave you a little bit more of a screenshot here. So in this case, I made a graph of area in centimeters square versus radius square in centimeter square. And when we did that, we got a straight line with a slope of 3.13. And the unit we have to figure out, well, rise over run. That would be a centimeter square over a centimeter square. And something should tell you what happens when you divide those two. And then our intercept, see if we can look at that intercept again. What was it? Something times 10 to the negative 15, 4.26 times 10 to the negative 15. I think that's the smallest one I've ever seen. And the unit would be whatever the unit of my y-axis is. So my y-intercept, that would be centimeter square. So here we go. Step number 1, follow this out. Write the mathematical equation for the graph. Well, it is a straight line. Thank you very much. Plus b. Step number 2, replace my y and my x. And I suggest if you don't have it, you jot that down somewhere, screenshot it where you can hang on to it because you're going to do it a lot this year. So in place of y, I'm going to write a. Some people would have you write your unit there too. It just gets a little cluttered for me. And that's just my personal preference. In place of x, I'm going to write radius square plus b. Step number 3, replace m with what I've actually graphed. So for me, it's 3.13. What have I got here? Centimeters square per centimeter square, which, yes, I know, completely cancels. So you famous unitless numbers near 3.13. It should seem very familiar to you from the last lab. Plus b, which is 4.26 times 10 to the negative 15. Okay, well, I'm not going any further in this lab. You can probably guess that 10 to the negative 15, you can make 0. So step number 4 is write an equation based on the slope that you got from doing this graph. Write an equation. So in other words, area is equal to something times r squared. And so something tells me you've seen this equation a lot of times, but now you've actually proved it by doing the lab. So anyway, hope this helps, and good job, and we'll talk to you later. Bye.